Is Uranus actually a rock giant? For decades, we've believed we understood Uranus, a frozen, distant ice giant made mostly of water, methane, and ammonia. But what if that picture is completely wrong? What if beneath its calm blue atmosphere, Uranus is hiding something far stranger, a planet that might not be an ice giant at all, but a rock giant, a world built more like Earth than we ever imagined, buried beneath thousands of kilometers of crushing oceans and alien storms? And if that's true, then our entire theory of how planets form in the solar system may need rewriting, because Uranus might be the biggest planetary imposter we've ever discovered. Uranus is one of the strangest worlds in the solar system. It spins on its side. Its poles experience 42 years of sunlight, followed by 42 years of darkness. It's also the coldest planet in the solar system, with atmospheric temperatures dropping to nearly -224 degrees Celsius. Yet, despite these oddities, scientists thought they understood its basic identity. For decades, Uranus and its neighbor Neptune were classified as ice giants. The idea was simple. Deep inside these planets lies a small rocky core, surrounded by a vast mantle of water, ammonia, and methane, compressed into a superheated ocean under unimaginable pressure. Above that floats a thick atmosphere of hydrogen and helium, giving Uranus its soft turquoise color, a simple three-layer structure: rock core, icy mantle, gaseous atmosphere. But in science, simple explanations rarely survive new data, and Uranus may be hiding a far more complicated interior. The problem begins with a simple question: how do we know what's inside a planet we've only visited once? The only spacecraft to ever see Uranus up close was Voyager 2 during its famous flyby in January 1986. The spacecraft spent only a few hours near the planet. That brief encounter gave us measurements of Uranus's gravity, size, magnetic field, and atmosphere. From those clues, scientists built computer models of the planet's interior. But these models were always built on assumptions. Assumptions about how planets form, assumptions about what materials should exist there. And recently, some scientists decided to test what happens if those assumptions are removed. In a recent study, planetary scientists ran thousands of new computer simulations of Uranus's interior. But this Jimmy Dutt called an agnostic approach. Instead of forcing the planet to match traditional models, they allowed the simulations to explore any possible composition that fits the observations. They adjusted ratios of rock, water, methane, and other materials. Then they compared each model with real data from Uranus, things like its gravity and density. Slowly, thousands of possibilities were eliminated until only a few potential interiors remained. And the results were shocking, because many of the surviving models suggested something unexpected. Uranus might contain far more rock than ice, possibly even more rock than water. In some scenarios, the rock-to-water ratio was nearly 4:1, which would make Uranus something scientists had never seriously considered before: a hockey giant. To understand why this matters, imagine building planets like layered cakes. A gas giant, like Jupiter, is mostly hydrogen and helium. An ice giant, like Neptune or Uranus, was thought to be a thick mixture of frozen compounds, water, methane, and ammonia, surrounding a rocky center. But if Uranus is dominated by rock instead, its structure would look very different. Picture a world where a huge, rocky interior stretches thousands of kilometers deep. Above that rock could sit an enormous ocean of superheated water, hotter than lava, but squeezed so tightly by pressure that it behaves like a dense liquid. And deeper down, conditions become even stranger. Pressures inside Uranus may reach 600 gigapascals, 6 million times Earth's atmospheric pressure. At those extremes, methane molecules break apart. The carbon atoms left behind could be compressed into solid diamonds. Scientists believe these diamonds might literally rain downward through the mantle, sinking toward the planet's interior. A bizarre, phenomenon often called diamond rain. But if the rock fraction is larger than expected, this whole internal structure changes. The rocky layer could be much thicker, the mantle could behave differently, and Uranus might resemble a gigantic, scaled-up version of a terrestrial planet wrapped in alien oceans. Of course, this idea raises an important question. If Uranus contains so much rock, how did it form that way? Scientists have a few possible explanations. One idea is that Uranus formed in a region of the early solar system rich in rocky debris, allowing it to gather more rock and metal than ice as it grew. Another theory suggests a massive collision with a protoplanet several times the size of Earth. Such an impact could have added large amounts of rock to Uranus and may also explain its unusual 98-degree tilt. A third possibility is that the planet's interior formed in layers, with dense rock sinking deep inside while lighter materials stayed above. These layers could trap heat within the planet, potentially explaining another long-standing mystery about Uranus. Uranus is the coldest planet in the solar system, and that's surprising. Most giant planets still release large amounts of leftover heat from their formation. Jupiter radiates almost twice as much energy as it receives from the Sun, and Neptune releases even more. But Uranus barely emits any internal heat at all. For years, scientists couldn't explain why. One possibility is that thick layers deep inside the planet trap the heat, preventing it from escaping like a cosmic thermos bottle. If Uranus truly is rock-dominated, the implications reach far beyond one planet. Because astronomers are discovering thousands of exoplanets around other stars, many of them fall into a mysterious size category called mini-Neptunes. These worlds are similar in mass to Uranus and Neptune. Today, Uranus remains one of the least explored worlds in the solar system, a distant turquoise sphere drifting silently through space. But beneath its calm appearance could lie superheated oceans, diamond storms, and perhaps a massive rocky heart. If that's true, Uranus may not be just an ice giant, but a completely different kind of world, one that could change how we understand planets across the galaxy. And if you want to explore more incredible mysteries of the universe, make sure to like the video, subscribe to the channel, and join us for the next journey into space.